Welcome back to the deep dive. I was thinking about my relationship with school this morning. I have this distinct memory of math class.
Oh, yeah.
For years, I was winning. I mean, I could memorize the multiplication tables, I could do long division, I was great at the rules. But then, somewhere around late high school, maybe it was pre-calc, maybe calculus, I hit a wall hard.
You are definitely not alone in that.
It felt like the game changed, but nobody told me the rules had changed. It was like I was playing basketball my whole life, and suddenly I walked onto the court and everyone was playing
Water polo.
water polo, and I'm just standing there holding a basketball, totally confused.
That is a surprisingly accurate metaphor for what we're covering today. We often teach math as this single continuous ladder. You learn step one, then step two. But we rarely stop to explain that there are actually different types of ladders, or that the architecture of the house completely changes when you move from one room to another.
Exactly. And that brings us to today's source. We are looking at a document titled The Realm and Continuum, Foundations of Mathematical Combination.
Right.
Now, I have to be honest with everyone right up front. This is technically a specification for a fifth grade educational framework.
Technically, yes. It's a curriculum proposal.
But, and this is a big but, when I read it, I wasn't thinking about fifth graders. I was thinking about my project management software. I was thinking about how I argue with my spouse. I was thinking about why some corporate strategies fail miserably. This document claims to offer a grand, unified theory of logic based on a single, simple question. How do things combine?
It's incredibly ambitious. The central premise is that the complexity of the universe, whether we're talking about quantum mechanics, algebra, or, a team meeting, boils down to a binary distinction.
Just two ways.
The source argues there are only two fundamental ways that things can combine.
Two ways. That's it. And the argument is that because we don't teach this distinction early on, literally in elementary school, we end up with adults who try to solve complex problems with the wrong set of tools. We're using a hammer on a problem that requires, I don't know, a paintbrush.
Or, to use your earlier analogy, we're trying to dribble a basketball in a swimming pool.
Right. So our mission today is to unpack this framework. We need to understand these two modes, the realm and the continuum. And I want to see if this actually holds up when we map it to high-level math and, more importantly, to our actual lives.
Let's dive in.
Okay, first up, the realm. The document calls this non-interfering combination. That sounds a bit technical, so let's break it down.
The key concept here is identity. In the realm, when you bring two elements together, they maintain their distinct identities.
Okay.
They're essentially strangers standing next to each other in an elevator. They are near each other. They might even be grouped together, but they don't change who they are.
The analogy the document uses, and I think this is the anchor for the whole theory, is Lego bricks.
It's the perfect visualization. Imagine you have a red Lego brick and a blue Lego brick. You snap them together. You've created a combined structure, right?
Right, a red-blue unit.
It's now a red-blue unit. But look closely. The red brick is still 100% red. It's hard plastic. It has 8 studs. The blue brick is still 100% blue.
The active combination hasn't changed them.
Not at all. Their internal nature is the same.
And crucially, it's reversible. You can unsnap them.
Exactly. The structure is decomposable. You can get back exactly what you put in. This is what mathematicians often refer to when they talk about commutativity.
Where order doesn't matter.
Order doesn't really matter effectively. If I put the red brick on the blue brick, or the blue brick on the red brick, I still have the same 2 bricks. It's just a list of parts.
So if we take this out of the toy box and into the real world, a grocery list is a realm system.
Ideally, yes.
If I write hot sauce and then I write ice cream on my list, the ice cream doesn't suddenly become spicy just because it's next to the hot sauce on the paper.
We hope not. The items are distinct. A spreadsheet is another perfect example.
Oh, yeah.
Cell A1 does not bleed into cell B2 unless you write a formula that explicitly tells it to. It's a world of discrete, safe, separate boxes.
It feels very orderly. It's safe. It's the world of inventory. I have 5 chairs. I add 2 chairs. I have 7 chairs. The chairs don't merge into a mega chair.
Correct. That is the realm. But the universe isn't always made of Legos.
Right.
Sometimes things get messy.
Which brings us to the second mode, the continuum.
This is interfering combination. This is where the identity of the elements is fundamentally altered by the act of combining them.
And the analogy here flips from Legos to mixing paint.
Right. Take that same red and blue from the Lego example.
Right.
But now there are wet acrylic paints. You mix them together. You don't get red next to blue. You get purple.
And you can't get the red back.
Not easily.
No.
The structure is not decomposable. If I hand you a bucket of purple paint, you cannot separate it back into the original red and blue simply by pulling them apart. The redness and the blueness have interfered with each other to create a new emergent property.
Emergence. That's a heavy word in systems theory. The document says in the continuum, new emergent behavior appears that wasn't present in the parts.
Think about sound. This is a great example. If I play a C note on a piano and you play an E note,
we get a major third. It's a chord.
We get a chord. But think about the physics of that. The sound waves are physically interfering in the air. The texture of the sound is something new. You aren't just hearing two isolated beeps. You're hearing a blend, a harmony, or a dissonance.
That's continuum logic.
Exactly. The whole is different than the sum of the parts.
So the core thesis here is that confusion arises in math and in life when we try to apply Lego logic to a paint world.
Or vice versa. We try to force things that are blending to stay separate, or we treat separate things as if they are blending.
The document makes a pretty bold move here, though. It doesn't just leave this as a philosophical idea for kids. It maps these two modes directly to the standard curriculum of mathematics.
It does.
And this is where I think my high school trauma gets explained.
It creates a map of the territory. It essentially divides math into the math of Legos and the math of paint.
So let's look at the mapping. The realm maps to algebra.
Correct. And think about why.
Well, in algebra, I'm moving x and y around. X is distinct, y is distinct. Even if I have a huge polynomial equation, the variables are like little containers holding their value.
Exactly. Algebra deals with discrete structures. Groups, rings, fields, vector spaces. Even when you get into complex matrix addition, you are essentially summing up components.
You're stacking bricks.
You are stacking bricks. The rules of algebra are designed to preserve the identity of the variable across operations. If x equals 5 at the start, x is still holding the value of 5 inside the equation structure.
Okay, but wait. I need to pause on something. The document mentions vector addition is part of the realm. That tripped me up for a second because vectors have direction, they indicate movement, they feel like physics, they feel flowy.
It is a nuance, but it's a critical one. Think about the parallelogram law in physics. If you have vector A pushing north and vector B pushing east, you add them together to get a diagonal resultant vector.
Right.
But, and this is the key, you can perfectly decompose that result back into A and B.
Ah, okay.
The north push and the east push are still there, acting independently within the result. It's linear, it's additive, it doesn't undergo a chemical change.
So complexity doesn't mean continuum. A vector space can be incredibly complex, but it's still Legos because you can take it apart.
Precisely. You can build a life-size model of the Death Star out of Legos.
Yeah.
It involves millions of pieces, it's massively complex, but it is still in the realm. It's still discrete parts snapped together.
Okay, that clicks. So then the continuum maps too.
Analysis.
Analysis, calculus, differential equations, Fourier analysis.
This is the math of the smoothie.
It is. Calculus is the study of continuous change. When you are looking at a curve or a rate of change, you can't easily break it down into discrete bricks. You have to use limits. Limits, I remember limits, as x approaches 0.
A limit is essentially a trick, a brilliant trick, to bridge the gap between the two worlds. It's how we use discrete numbers to describe continuous flow. But the logic is different.
How so?
In the realm, you count things. In the continuum, you measure change. In the realm, things are static objects. In the continuum, things are flows, waves, and rates.
This explains why so many people hit that wall at calculus. I was good at algebra because I liked the click of the Legos. I liked that I could move things around and they stayed the same. Then calculus came along and it felt like, well, like trying to nail jelly to a wall.
You are likely trying to use realm thinking on a continuum problem. The source argues that if we told students, hey, you're entering a new universe with new physics, they wouldn't be so confused.
Well, we don't.
Instead, we just say, here's the next chapter in the book, as if it's the same thing.
The document talks about specialized transforms needed for the continuum.
Right. You can't just add your way through a differential equation in a simple sense. You need transforms, like the Fourier transform, to make sense of the blending. You have to understand how the waves overlap and interfere.
It's a different toolkit.
Completely.
So the educational proposal here, the phase 1 of this curriculum, is to teach this before numbers.
Yes. The source argues that before a student ever memorizes 7 times 8, they should look at a pile of rocks and a glass of water and be able to say, rocks are realm, water is continuum.
It's training intuition.
It's building a mental model for abstraction. If a child understands that some systems preserve identity and some systems blend, they're insulated against that shock later in their education. They have a category in their brain for the blending math.
I love that idea, but the source goes further than math. Phase 4 of the instructional model is real-world application. And honestly, this is where I think the value lies for our listeners who aren't currently studying for a calculus exam.
This is cognitive transfer. That's the goal. Using the math model to debug real life.
Let's talk about that in the workplace. The document mentions teamwork and conversation. I found the conversation analysis really striking because I recognized myself in it.
It classifies conversations into realm and continuum.
A realm conversation is, what, fact swapping.
Essentially, think of a status update meeting. I tell you the project status, you tell me the budget numbers, my information lands next to your information.
We're stacking bricks.
We are stacking bricks. Here's my update. Here is yours. It's efficient, it's necessary, but it's non-interfering.
And a continuum conversation.
That's the brainstorm. That's the jam session.
Yeah.
I say something half-formed. That sparks a connection in your brain, so you say something that changes my original idea. We are modifying each other's thoughts in real time.
We are making purple paint.
We are creating an emergent idea that neither of us had when we walked into the room.
Here is where I see the friction, though. I've been in meetings where we are supposed to be brainstorming, we're supposed to be in the continuum, but there is that one person who is stuck in the realm.
The person protecting their Lego brick.
Yes. You suggest a tweak to their idea and they get defensive. No, that's my idea, don't change it. They're treating their contribution as a discrete, owned object.
That destroys the continuum. You cannot mix paint if you keep the lid on the jar. If you are in a creative problem-solving mode, you have to surrender identity. You have to let your idea merge with the group's idea.
But the reverse is also disaster. I'm thinking of those meetings that drag on forever because we're trying to blend on something that should just be a decision.
Oh, absolutely. Design by committee is often a misapplication of continuum thinking to a realm problem.
Oh.
If you need to assign tasks, you call the vendor, I'll write the code. That is the realm.
Right.
You need clear boundaries. You don't want blended responsibility. That just means nobody does it.
I see this in project management all the time. There's that famous concept, the mythical man month. Adding more people to a late software project makes it later.
That is a perfect application of this theory. Management thinks it's a realm problem. We need more bricks, so add more people.
Simple addition.
Simple addition. But a software team is a continuum system. When you add new people, you increase the communication overhead, the training, the interference. You aren't stacking bricks. You're pouring more paint into the bucket and messing up the viscosity.
So the skill, the mastery, defined in the assessment section, isn't just doing the math, it's classification, it's reading the room.
It's asking, what is the structure of the problem in front of me? Is this a situation that requires rigid, decomposable accountability? Or is this a complex system where everything influences everything else?
This touches on the systems thinking section of the source. It mentions that we often try to manage culture like a spreadsheet.
That's a classic error. Corporate culture is a continuum phenomenon. It's an interference pattern of behaviors, incentives, and beliefs. But management loves the realm because the realm is measurable. We want a KPI. We want a metric.
If we just add a Pizza Friday brick to the stack, morale will go up.
Exactly. We treat it like an additive equation. But culture doesn't work that way. A Pizza Friday might interact with mass layoffs to create a very cynical, toxic shade of paint.
Wow.
You can't just stack the good on top of the bad and expect a simple sum.
That's a powerful image, the interference pattern of a company. It reminds me of relationships, too. If you're keeping score, I did the dishes 3 times, so you owe me 3 favors. That's realm thinking.
And that's usually a sign of a troubled relationship. A healthy relationship is continuum. It's a partnership where the contributions blend. You aren't 2 people standing next to each other. You are a we. The identity has shifted.
But if you try to do your taxes with continuum vibes, the IRS is going to be very unhappy.
The IRS is strictly realm. Please keep your receipts discrete and decomposable.
I want to go back to the educational aspect for a moment. The source argues that this should be the very first math lesson. 5th grade seems young for this level of metacognition. Do they really think a 10-year-old can grasp non-interfering combination?
I actually think 10-year-olds are better at it than we are. They haven't been rigidly conditioned yet. They intuitively know that mixing mud is different than stacking blocks.
That's true.
The curriculum isn't asking them to solve partial differential equations. It's asking them to sort pictures.
Phase 1 is intuition. Here is a smoothie. Here is a pile of coins.
Right. And by formalizing that intuition early, you give them a language. Imagine if a fifth grader could say, "Teacher, I'm confused because I'm trying to use realm rules on this fraction problem, but it feels like the numbers are blending."
That is an incredible level of
It
self-awareness.
turns a student into a diagnostic thinker rather than just a calculator.
And that's the future of work, isn't it? The calculators are digital now. We have software to do the realm work. We have software to do the continuum math. What we need are humans who know which software to use.
Is this a screwdriver problem or a paintbrush problem?
That's it. That is the fundamental core of logic.
It's interesting. The document closes with the thought that all of mathematics branches from this first distinction. It's almost spiritual in a way.
How do you mean?
It suggests a binary structure to the universe, things that stay themselves and things that become something else. It resonates because it's true physics.
Why?
At the quantum level, you have particles, which are discrete, countable things, and you have waves, which are continuous, interfering flows. This tension between the part and the whole, between the individual and the flow, is the story of everything.
So if we take this sort of big picture view of the document, the key takeaway is stop looking at the difficulty of the problem and look at the structure of the problem.
Yes. Complexity is not the dividing line. Identity is the dividing line.
I like that. You can have a simple realm problem, like 1 + 1, or a complex realm problem, like building a rocket ship.
And you can have a simple continuum problem, mixing two colors, or a complex one, predicting the weather. And the error comes when you cross the streams.
So, for you listening, here is the challenge as you go back to your day. You have a stack of problems on your desk. You have relationships to manage. You have a career to plan.
Don't just dive in and start working. Pause.
Ask the question, am I stacking Legos or am I mixing paint?
If you are treating a paint problem, like your relationship with your team or your brand's reputation, as a Lego problem, you are going to be frustrated because the pieces won't stay where you put them. They will flow.
And if you are treating a Lego problem like your budget, your inventory, or your project timeline as a paint problem, you're going to end up with a mess where nothing counts and nothing is accountable.
Match the tool to the territory. It sounds simple, but it changes everything.
Who knew a fifth grade curriculum could be the key to fixing our management headaches?
Sometimes you have to go back to the foundation to fix the cracks in the ceiling.
Thanks for taking the deep dive with us.
Always a pleasure.